Hello everyone and good morning. I hope you all are doing good and well. So today in the class, what we are going to do, we will be discussing questions from wave motion. Okay? So just give me 1 minute. I need to check something. After that, I will be getting back here. Okay? Just give me something. Okay, let's start with the questions. So we have wave motion. And we will straight starting from the questions, keeping in mind you already remember the basic formula, the formulas that you study for your JEE mains examination. So if you are aware of all those formulas, I mean you will be able to make it out. Okay. So even if not, then I mean at the end of this question, I will be first starting with the basic formulas and concepts that is required for doing this question. But before I start with all this, you should start with a question. So take your time, do it, and let me know. Yeah, read the question carefully. This is the most recent question. This came in 2024. Do it. You can send me options if you're getting at any of these options. If you got any answer, you can send me. Okay. Okay, so mm, you need to check more carefully. Yeah, that's correct. Yeah, that's correct. Okay, let's check with other things. Sohil, if you have got A, then you can easily check with option C. Okay, let us do it together now. So let's discuss this question. What is given in the question over here? There is two uniform string of mass per unit length mu and 4 mu and length L and 12 respectively, and they are joined at point O. So one is having lower density, another is having higher density. Their lengths are also different. One is L, another is 12. Now these two ends P and Q are fixed. So at fixed ends, if we are getting if we are getting standing waves, then these fixed ends will be what? I mean, there are two terms in standing wave. One is your node, another one is your antinode. So what do you mean by node? Node means a point having a minimum amplitude, that is zero. So here amplitude is what? Here amplitude is zero. And antinode meaning what? Amplitude is what? It is max. Okay? So these are two things. Now, so P and Q are definitely going to be what? They are going to be node with amplitude zero because they are fixed. Wherever we have studied the formation of the standing wave on the string, then if a if a string is fixed, then at fixed end you won't be getting maximum displacement because this is fixed, right? It cannot get displaced from here. So if it is fixed, you are sure to get what? Node. So P and Q, at P and Q you will be getting node. Now let's move ahead. The strings are under a uniform tension. So tension is same throughout the string, be it a string of linear mass density mu or 4 mu. So tension is going to be same. Now, if we define the frequency V naught, there is something given as V naught, which is equal to 1 by 12 into root under D by mu. Now, which of the following statements is our correct? So let's check the option A. In option A, what is getting said? With a node at O. If there is node at O, that is the point O is also having minimum not minimum, zero amplitude. Okay, minimum में negative भी जा सकते हो, but that is not treated as minimum amplitude. Modulus we take, so basically zero. The minimum frequency of vibration of the composite string is this. So, minimum frequency of vibration of the composite string we need to calculate. How we will do? Let's talk about first the first string. So for first string, if you see, point P is fixed, point O is also fixed because at O we are going to get node. So first mode that can get excited will look like this. Then similarly, in another string of linear mass density 4 mu, here also first mode that can get excited will look like this. Okay, so let's say here wavelength is lambda 1, here it is lambda 2, then lambda 1 can be lambda 1 by 2 can be written as what? L, because whole lambda is what? Whole lambda is this distance. So if we talk about just separation between these two things, then it will be lambda by 2. So lambda 1 by 2 is L, and similarly lambda 2 by 2 is equal to how much? This is your 2L. Okay, so these are two things we are noticing. After that, if you break the, I mean, if you talk about the n number of vibrations, I mean, this is the fundamental frequency ka case will be like this. If two ends are fixed, then fundamental will look like this. Second will look like what? It will look like this. It will look like this. And if you talk about third on the same string, sorry, I increased the length of a string, so it will look like this. ठीक है. So if we talk about the general formula of frequency, जैसे यहाँ से अगर आप fundamental frequency निकालते हो, lambda 1 is equal to what? 2L. lambda को हम क्या लिखते हैं? V by wavelength ही right? Lambda is written as what? Lambda is written as what? It is written as C by uh, I mean एक second. Velocity by wavelength को आप क्या लिखते हो? This you write as frequency. So lambda can be written as V by F. So let's say this is V. V by F. F naught can be written as 12. So velocity can be written as what? Or frequency can be written as what? Sorry, V by 12. So fundamental frequency here will be equal to how much? V naught by 12. And here it will be equal to how much? In second case. So in second case, L is getting replaced by 12. So similarly here fundamental frequency will be 1 by 4L, I mean 2 into 2L, you will write it. So ऐसा कुछ लिखो, your length is different, right? So only that is bringing the difference. So 2 into 12, and here this is what? V. Then if you talk about the general frequency case, so here it is F naught is equal to how much? V by 12. What will be F naught here? If you calculate frequency here, so F1 is V by L. Because here this L length will be equal to lambda, and lambda can be written as what? Velocity by lambda is frequency. So lambda can be written as V by F. So F is V by L here. So that is why I've written this. Done it. So general formula, if we write about the frequency on this string, we will be writing as what? We will be writing as NV by 12. And if general frequency ka formula, if we write on second string, then that can be written as, let's change the integer. So MV by 4L. This will be the formula, right? And if the composite string, minimum frequency of vibration of the composite string is, if for the composite string, we are going to get the same frequency. I mean, we have to define here minimum frequency of vibration of the composite string. So what we will do is, we will try to see for what value of N and M, F1 will be equal to F2. Because we have to define single frequency for the composite string. So let's do this thing. अगर आप ऐसा करते हो, you will be writing here NV by 12, and this will be equal to how much? MV by 4L. MV by 4L. So if you check from here, अच्छा velocity को हमने अलग अलग नहीं लिखा. Velocity will be different here. Sorry, we will get it wrong. Let's say this is velocity v1, this is v1, and this is your v2, this is your v2. So velocity को आप लिख डालो फिर से. Velocity का general formula क्या लिखोगे आप? Root under t by mu. So in first case, it is n by 12. Velocity is how much? T by mu. And in second case, m by 4L, velocity is how much? Root under t by 4 mu. Okay? So if you cancel this out, it will become how much? L will get cancelled. This 2 will get cancelled. And here you will get n mu t will get cancelled. N is equal to m by 4 you are going to get. And so 4n is equal to n. Okay, so this is the relation we are getting for F1 to be equal to F2. Now coming back to the first thing, with node at O, the minimum frequency of vibration of the composite string. So for minimum frequency of vibration of the composite string, we need to take here the minimum integer. So M का minimum value क्या हो सकता है? For both M and N standing as an integer. So for that we can take N equal to 1. Minimum value of N can be what? 1, and then only we will get minimum value of M. So in that case, M का value क्या हो जाएगा? 4. So if you put N equal to 1, then if you put N equal to 1, what is the frequency that we are getting? We will be getting V by 12. V is here what? T by mu root under, and that is 1 by 12. So this is the frequency we are going to get, composite rod ka minimum frequency. So F naught is equal to this. And yeah, this is equal to V naught, right? Mu naught, 1 by 12 root under T by mu. So option A is what? Option A is going to be correct. Agree? Okay, so option 1 will be, you simply needed to remember the formula. String fixed at both in देखो इतना मैंने explain किया, thinking maybe you are not remembering the formula, but simple formula is what? NB by 12. Okay, for both strings sharing the same frequency, you have to simply compare NB1 by 12 is equal to MV2 by 2 into 12 because length is 12. Simply equate it, you will get relation between N and M, and for minimum frequency of the composite rod being same, you just need to select integer in such a way that you are getting minimum value of N and M. So here we did that, N equal to 1, M equal to 4. For that we got minimum frequency as what? Mu naught, right? Now if you look at the option C, I mean B is incorrect because with an anti-node at O, okay, in the case B, it is saying that if you are taking, sorry, I'm not taking it correct. Option B में ये कह रहा है with an anti-node at O. If you are taking anti-node at point O, The minimum frequency of vibration of the composite string is this. Again, you can calculate. If you're taking anti-node at O, what it will look like. So O is becoming free end. ठीक है? So ये क्या बन रहा है? Free end बन रहा है. This is your fixed end and this is also fixed. So for first string, if you see, fundamental will look like this, and for second string again, fundamental will look like this, because that open end amplitude will be maximum. Okay, so if you now use the general formula, so general formula is what? 2n plus 1 v by 4l. This is the general formula when one end of the string is fixed and another end is what? Another end is not fixed. This is the general formula, right? So here also you can do the checking. आप लोग कर लेना है इसको. क्या करोगे? 2n plus 1 v by 4l will be equal to 2m plus 1 uh, 4 into 2l, because here length is 12. This is 12. This is L. Into V2, you will write V1. V1 and V2 का value क्या है? V1 is root under T by mu. V2 is root under T by 4 mu. So you will put the value and you will try to see what is the minimum frequency you will be getting. You can check the option B. Same as option A. So we don't need to solve it. Option C को देखते हैं. When the composite string vibrates at the minimum frequency with a node at O, that is in case 1, it has 6 nodes including the end nodes. So if composite string vibrates at minimum frequency with node at O, we calculated just now the value of that minimum frequency. We got n equal to 1 and m is equal to how much we got? 4. What is the meaning of n equal to 1? N equal to 1 has this simple meaning. What is the meaning of this m being equal to 4? So here you will be doing this thing. Okay? 1, 2, 3, 4. Okay? Now, if you see here, I mean, m equal to 4 we have kept, right? So if you see here, 1, 2, 3, 4, 5, 6. How many nodes we are getting? This is first node. This is second node. This is third. This is fourth. This is fifth. And this is sixth. Because we were asked including the end nodes, right? Including the end nodes. So we will be getting how much? How many? 6, right? Because n is 1, meaning there is only one wave getting excited like this. M is equal to 4, meaning such 4 waves will get excited. So it will look something like this. So just count the number of nodes. So here it is equal to how much? It is equal to 6. Okay? Now option D में अगर आप आते हो, no vibrational mode with an anti-node at O is possible for the composite string. So if you are able to solve B, you will be getting the answer of D also. Because here it is saying no vibrational mode with an anti-node O is possible for the composite string. So if you will be solving for this, these two won't be, I mean, becoming equal for any integer value of n and m. So you just need to solve this. And अगर मैं आप लोगों के लिए यहाँ पे solve करूँ, तो what I will be doing, जैसे यहाँ से 2n plus 1 एक काम करती हूँ, करके दिखाती हूँ. So 2n plus 1, v1 को क्या रखोगे? t by mu divided by what you will be doing? 4l. ठीक है? And this is equal to how much? 2m plus 1. And this is your t by 4 mu root under divided by how much? Divided by 4 into 12. This is what we are going to get, right? So L you will cancel, 4 will get cancelled. This is 2. And this T by mu will get cancelled. Root under 4 will come down. That will become 2. So this will become 4. And here if you check, 2n plus 1 divided by 2m plus 1 is equal to 1 by 4. Or if you check here, एक काम करो, इसको मल्टीप्लाई कर दो. So 8n plus 4 is equal to 2m plus 1. Now you just look at the equation. 8n plus 4. This is always going to be even, right? क्योंकि 8 into whatever you do, you will get 8 into 2 16, 3 24, 4 I mean 32. So even, and with even you are adding 4, you will get even. So this whole term is even, right? And this term for m integer, it won't ever be even. कि हमेशा क्या होगा, ऑड होगा, ठीक है। सो इवन को आप ऑड से इक्वेट नहीं कर सकते, राइट। सो दिस इक्वेशन इज नॉट ट्रू, not true for n and m being integer, and that is why option जो आपका ऑप्शन होगा, कौन कौन सा ऑप्शन है, ए और सी, I mean no vibrational mode is, no vibrational mode with an anti node at O is possible. Yes, it is true. No vibrational mode is possible because this equation is not holding true for n and m being integer, right? डन है। सो ऑप्शन डी क्या दिख रहा है, करेक्ट दिख रहा है। ऑप्शन सी ये निकाला ही नहीं जा सकता, सो टू बी नॉट आने का कोई क्वेश्चन नहीं है, इट इज रॉन्ग, ठीक है। सो करेक्ट ऑप्शन इज व्हाट, ए सी डी, ठीक है। सो सिंपली बाय यूजिंग द फॉर्मूला एंड लिटिल बिट ऑफ कैलकुलेशन वी कैन डू सच थिंग्स। नाउ लेट्स हैव अ लुक ओवर दिस क्वेश्चन, ट्राई डूइंग इट एंड लेट मी नो, ठीक है। चलो करो तुम लोग। Any needs? How you calculate the velocity along the string of wave? I mean, if a string is not massless. If it is massless, then there is no question because tension will remain the same. And velocity you can easily write as root under T by mu. But here in this case, a string is not massless, right? है ना? Constant mass per unit length it is having. So it has uniform mass density mu. Done it? And in this case, we have to talk about the time taken for wave to reach from A to O or O to A. So basically, time taken means you need to deal with the velocity. Done it? And velocity here of the wave along the length of a string is not going to be constant. It is going to be a variable. So keeping that in mind, and also the pattern of how velocity will change as it will move, wave will move from O to A, or as wave will move from A to A. Because here you don't need to exactly calculate it. Even if you know the trend, how the variation is going to occur, you can solve the question. So try it. Yes. चलो ठीक है साथ में करते हैं. Let's understand it. So there is a block M that is hanging vertically at the bottom end of uniform row having mass density linear. ठीक है? A transverse wave pulse of wavelength lambda naught is produced at point O. First, it is produced at point O, pulse 1, and it takes time TOA to reach to the point A, right? If the wave pulse of same wavelength is produced at point A, then it takes time TAO. We have to talk about what is the status of TAO and TOA. Okay? So if you write the velocity of wave, I mean, what will be the time? Time will be simply the distance traveled. Distance traveled is same, that is equal to length, and this by velocity, right? And since velocity is not constant, we need to calculate small time that it is taking to cross a small length, right? So we need to write dt, and dt is equal to how much? That is dx by v. If I'm talking about, let's say pulse is here and it is crossing this dx length, so it is at a x distance below the point O and it is crossing this dx length, what will be the velocity? तो velocity को आप कैसे लिखते हो? Velocity you write as t by mu. Here tension mu is constant, right? Tension is the thing variable here. Tension हम कैसे निकालते हैं बताओ? Tension अगर मुझे किसी भी point पे निकालना है rope का, suppose here we have to calculate the tension, because here the wave is passing through this dx length, so across the dx length, what is tension in the string? That we need to check. So whatever mass is lying below it, that will contribute in its tension. And that is why in the case of massless string, tension is same throughout. Because mass distribution is not there on the string, it's not going to change the tension. So यहाँ पे, if you look at carefully, this length is what? I mean, if this is x, then this is L minus x. And what will be the mass of this? So its mass is L minus x mu, and and this capital mass is, so total mass hanging below the strip dx is how much? M plus L minus x mu. So what is the tension? T will be equal to mass into g, right? Because system is in equilibrium. So here you will be writing this plus M into g. will be equal towards tension, and this by mu is going to be your velocity. So this is velocity. You will be writing here the same thing, dx by this term, okay? And then you will be calculating what total time that it is taking. X will vary from 0 to 8. So when the pulse is at point A, let's talk about this. When the pulse is at point A, or this was O, right? Yes, that is point O. Tension was maximum, right? Because maximum weight mass is hanging below it. Maximum weight is there. Here tension is maximum. As it will come down, tension will decrease, decrease, decrease. Here the tension is minimum, and here tension will be equal to how much? Mg. ठीक है? This is going to be the case. Now, when the wave is moving from A to O, again it is moving from low tension point to the high tension point, such that velocity at any strip dx will be same as, जैसे suppose कर लो यहाँ से pulse चला था. Let's talk about any random position A. So at any random position A, if we indicate this point A on both the cases, then at this point for both waves, velocity will be what? Same. Then only the difference is one is coming down and another is going up. So velocity profile for this pulse traveling from O to A or from A to O is same. Only the difference is that for one it is what? It is decreasing, and for another it is increasing. So that average velocity is constant. And if average velocity is constant, time taken will be what? Time taken is going to be same. Okay? So you can clearly answer this thing. This time taken will be same. Now the wavelength of pulse 1 becomes longer when it reaches point A. So suppose कर लो point A पे reach कर गया है वो. Wavelength, how we calculate? Velocity by wavelength is equal to frequency. This is the relation, right? We already know when pulse is traveling through a media where velocity is changing, then wavelength will change, velocity will change, such that frequency will remain constant. So frequency is going to be constant. Now, if you say here wavelength was lambda naught, here velocity was what? Maximum. And here velocity is what? Minimum. So if at this point velocity is minimum, lambda will be equal to what? V by F. If V, I mean F is constant, V is minimum, then lambda will be also minimum. So the point is the wavelength of pulse 1 become longer when it reaches point A. No, it won't become longer. It is wrong. ठीक है? Now let's come to the point C. The velocity of any pulse along the rope is independent of its frequency and wavelength. Yes, velocity is merely equal to T by mu. So it is depending on tension and mass per unit length. So that's true. Uh, yes, that's true. Now, coming to the option D, the velocities of two pulses are same at the midpoint of the rope. Yes, they will be same at midpoint of the rope. Because if you talk about midpoint, tension here is for both waves going up or going down. At this point, tension will be same, right? If tension is same, then velocity will be what? Same. So D is also correct. Options correct will be what? A, C, D. Okay, everyone clear with this so far? किसी को कोई doubt है? Okay, चलो ठीक है. सोलो क्लियर है देव, ठीक है. चलो आगे बढ़ते. And let's do this question. This is a simple question. Just I have included for revising the formula. So let's do it and revise the formula. Everyone get along it. I mean, do it. This is the question you got in your mock 3. Yes. Anybody? Any answer? Okay, let's discuss the question now. So there is a bus moving towards a huge wall. So this is a bus, okay? And this is moving towards a huge wall here. Let's say this is the wall. Now what is happening? This is moving with a velocity of 5 meter per second. The driver sounds the horn of frequency 200 hertz. So from here, a wave is getting generated, and that sound wave has a frequency of how much? 200 hertz. Done it? The frequency of the beats heard by a passenger of the bus will be what? So, what is beat? Beat is difference in frequency of sounds that you are getting to hear. So, difference in frequency basically. What does it mean? It has a simple meaning that one sound wave is getting generated by horn. So one frequency it is listening equal to 200 hertz. And in order to listen beat, it should hear another sound also. So another sound will come from where? ठीक है? कहाँ से आएगा? So the thing is simple. This wave will move forward. It will get reflected by this wall. इस wall से wave क्या होगा तुम्हारा? Reflect करेगा with phase change. Why phase will change? Because you already have heard when there is a rigid wall in front, then wave reflects back by changing its phase by an angle of 180 degrees. So that is why I have just taken it inverted like this. But in this question, we don't need to pay focus on this one. Simply thing is, wave will fall on the wall, it will get reflected. And this reflected wave, if it is coming like this, it will have some, it is having certain different frequency. Let's say F1, and then beat will be equal to what? This F1 minus 200 or 200 minus F1, depending on which one is larger or smaller. Okay? So how we will calculate F1? F1, it seems like it is getting generated by wall. Okay? So first wall is receiving a frequency of wave. First it is receiving, and then it is again reproducing that wave. Done it? So question is, which frequency of wave first wall will receive? ठीक है? Then we will say कि which frequency wave is getting produced by wall and getting heard by person sitting inside the bus. ठीक है? तो सबसे पहले what we need to check is 200 hertz की sound wave is moving forward. I mean, by this wall, which frequency of sound is getting received? क्योंकि यहाँ पे अगर बस तुम्हारा रेस्ट में होता, then wall will receive the same frequency of sound 200 hertz. Since bus is not at rest, Doppler effect will come into effect and wall will receive a different frequency. So frequency received by wall. क्या होगा बताओ? कैसे लिखोगे? Here what is happening? Receiver is who? Receiver is wall. So wall here is observer in first case. When we are calculating frequency received by wall, wall is what? Observer. Who is the source? Bus, horn, right? That is the source. So what is happening? Source is moving towards the observer. So this is a case of source moving towards observer. How you will write the frequency? So this is the conclusive formula basically, comprehensive formula I would say. It will accommodate all sort of things. Only sign convention you have to remember. So V plus minus V naught divided by V minus plus Vs into F naught. F naught is what? F naught is the incident frequency, incident wave का frequency. ठीक है? So here incident wave की frequency 200 hertz. It is getting received by wall. So which frequency is getting received by wall? For that you will see here. हमारे केस में क्या है? सोर्स कौन है? बस है. And who is the observer? Observer is your wall. Definitely wall is at rest and it is moving with certain velocity, right? So source is moving towards the observer. ठीक है? So when ऑब्जर्वर की वेलोसिटी जीरो है, वी नॉट को आप जीरो कर दो, सिंपल. सो वी बाई, नाउ द क्वेश्चन इज माइनस होगा या प्लस होगा, क्या लिखोगे? सो साइन कन्वेंशन याद रखना, हम प्लस तब लेते हैं ऑब्जर्वर टुवर्ड्स द सोर्स देन प्लस, एंड इफ यू डू द ऑपोजिट ऑफ इट, सोर्स मूविंग टुवर्ड्स ऑब्जर्वर, इट विल बिकम नेगेटिव. So here source is moving towards the observer, so that will become negative. So यहाँ क्या लिखोगे, V minus Vs into F naught. ठीक है. So what frequency is getting received by the wall? V by V minus Vs into F naught. Now the question is, अब क्वेश्चन कैसा हो गया, दिस वॉल इज नाउ बिकमिंग द सोर्स, क्योंकि जो लाइट जो साउंड रिफ्लेक्ट होकर आएगा, that sound will again get heard by person sitting inside the bus. So person sitting inside the bus is hearing first 200 hertz frequency wala sound original, and another reflected from the wall. So when this sound wave will get reflected from the wall, this wall will act as a source, and person sitting inside the bus is receiving this sound wave. So this person will now become observer. So second case में अगर आप देखो ना, तो case is what, observer is moving towards the source because bus is moving towards the wall. So this is a case of observer moving towards the source. Then what will be the frequency of light getting heard by this observer? So from here incident I mean, अगर ये बस रेस्ट में होता, अगर ये बस रेस्ट में होता तो उसको कौन से फ्रीक्वेंसी की साउंड सुनाई पड़ती, दिस वन. लेट्स से दिस इज F1, so F1 which is received by the wall, right? But since here observer is moving towards the source, it won't hear the sound of frequency F1. Again there will be the role of Doppler effect. So what will be the frequency now? So F2 को क्या लिखोगे, observer is moving towards the source is at rest, right? That is wall. So इसको आप जीरो कर दो. Observer is moving towards the source, so positive sign V plus V naught by V. So यहाँ पे क्या लिखोगे, V plus V naught by V into F1. ठीक है. This is the frequency this person will hear. Now let's solve it. अब आप देखो ये क्या होगा, बीट का नंबर क्या होगा, बीट विल बी सिंपली F2 माइनस F0, राइट? F2 को आप क्या लिखने वाले हो, F2 को आप लिखोगे V plus V naught by V. So you will write here V plus V naught by V in V by V minus Vs into F naught. So this is equal to V by V minus Vs into F naught minus F naught. So this will get cancelled, and this is V plus V naught divided by V minus Vc, sorry, V source equal minus into F naught minus F naught. Now put the value. Value क्या क्या है देख लो, 338 है and this is 5, right? So you just need to put the value 338 plus 5, 338 minus 5 minus 1 into F naught. You just need to put this value, you will get the answer. So this is how we treat with things in the Doppler effect. This is a very famous question given everywhere. So you should know when bus is moving towards a wall, sound will get reflected. That reflected sound will have what frequency getting heard by person sitting inside the bus. So you need to apply two things. First, the sound will get received by the, I mean, this is bus and this is wall. So frequency of sound getting received by wall is what? It is F1. And frequency of sound, reflected sound getting heard by person inside the bus is what? It has a frequency of F2. Okay. So what is the beat number? Beat number is original sound getting heard by this person, because this person is only hearing two sounds. One originally getting released by the whole, that is of frequency F0, and another reflected sound that has a frequency of F2. So beat will be simply F2 minus F0 or F0 minus F2, depending on frequency is getting higher or lower. Okay. So this is the beat thing you will be learning. Okay. Ahead also we have lots of questions from this, so we will do. Now let's practice this question. This is also your your mock question from mock 3. Last time I couldn't discuss in the classroom, I told you, because of time crunch. So I told you I will be discussing in the classroom when I will be revising the topic. So let's do it. This is actually important. That is why I included. This is interesting. So do it, everybody. सोहेल,
मैम प्रीवियस में डाउट प्रीवियस क्वेश्चन में
सीरियस क्वेश्चन।
मैम डॉपलर इफेक्ट इतना पढ़ा नहीं है तो एक डाउट आ रहा है कि मैम जब वॉल पे अगर पूछा जाए कि फ्रीक्वेंसी का बीट क्या होगा, तब मतलब बीट क्या सुनाई देगी ऑब्जर्वर अगर वॉल के पास हो, तो मैम क्या होता?
क्या क्या अगर?
F2 - F1, ऑब्जर्वर वॉल पे हो
हाँ
तो वॉल के नियर
हाँ।
स्टैंड हो, और फिर बीट उसे क्या सुनाई देगी?
आई मीन फॉर कैलकुलेटिंग बीट यू सिंपली नीड टू कैलकुलेट कि डब जो सेकंड फ्रीक्वेंसी ऑफ साउंड उसके पास आ रही है उसकी फ्रीक्वेंसी क्या है। सो आई मीन द वे वी कैलकुलेटेड इट विल बी सेम। या I mean, is calculation going to change in that case if it is very much near? So, if you have any leads, you can let me know.
ओके मैम।
Okay, you are doubtful about that? Okay, do this. I will recheck with that if you're having doubt in that, but I feel like that will be same. सोहेल, एक चीज हो सकता है जब आप वॉल के पास हो ना, एक केस होता है जैसे ऐसा सोच सकते हो, when it is crossing the wall in that case I think, लेकिन वॉल को यहाँ पे क्रॉस तो कर नहीं सकता क्योंकि दैट इज अ जायंट वॉल गिवन हियर। लेकिन हाँ, जब क्रॉसिंग का केस होता है ना, जैसे यहाँ पे एक सोर्स पर्सन है, बस है, इट इज क्रॉसिंग so near the wall, when it is I mean when it is just before the wall it is approaching the wall, when it is just after the wall it is receding away from the wall. So near the wall you will get different frequencies because of this thing, because यहाँ पे ऐसे सोचो, in first case observer is moving towards the source, and in second case observer is moving away from the source. Done है? So two different frequencies it will hear, one because of observer moving towards source, another because of observer moving away from the source. ठीक है? But such questions I mean in the case of wall it cannot be because this is a giant wall, you are not crossing it, right? You will simply, जैसे तुम imagine करो तुम्हारे रास्ते में wall है, how you will go? You will just go around it, you won't go cross it, right? And when you are going around it you are not receiving the reflected sound. ठीक है? रिफ्लेक्टेड साउंड को हियर करने के लिए यू शुड बी इन दिस रेंज, यू शुड बी ट्रेवलिंग इन दिस रेंज, एंड इन ऑर्डर टू गो अलोंग द वॉल, beyond the wall you need to travel in this range, right? Otherwise there will be accident, collision. So if you were confused about this case, then it is like there is a source, it is generating sound of certain frequency, there is one observer approaching it, so just near the source its frequency will be f1 here, and then at the moment when it is just going away from the source its frequency will be different. So here beat will be equal to how much? F2 minus F1. No case of that reflection or anything. Okay.
ओके मैम।
Okay. Okay. Anyone who got this? Any lead?
ये तो हो गया था।
अच्छा, हो गया था।
हाँ वो सॉल्व कर लिया था पेपर के वक्त ही।
ओके ओके।
4 ऑप्शन आ रहे थे इसके।
हाँ, all four options were there. ठीक है, डन है. So I will just take you through the formula. So here what is given? Y as a function of x is given. So there is a sound wave. Sound wave का equation आप कैसे लिखते हो? A sin omega t minus kx. ठीक है, और kx minus omega t, generally it is written like that. So let's write it conventionally. So like this it is written. What is the meaning of this x and y? That only you need to understand in this question. So whenever, I mean, there is air particles like this, whenever sound wave is passing through it, I mean, let's say this direction is x. और यहाँ से अच्छे से नहीं समझ पाओगे. I should take the case of transverse wave. Let's say there is a string and these are the atoms. Wave is what? It is energy. So when wave is entering here, that energy will get received by the individual atoms. And in this case, and in the case of transverse wave, displacement looks like this. Or the snapshot of displacement is this. It has a simple meaning that this snapshot, if you are taken at 1 second, then at that 1 second, this particle has jumped to this position. This one is at this position. This one is at this position. This, this is this. Okay? So this y is the displacement of particles from its mean position. X is the direction in which energy is traveling. Now the question is, y versus x graph is given. Particle located at S has what velocity at this point? What will be the velocity? Has zero velocity. Again, this is not your yt curve. This is not your yt curve. You cannot say dy by dt is zero here. Dy by dt is zero here. Slope is zero, and that is why velocity is zero. No, we really need to compare the velocity of particle. That is, we need to calculate dy by dt in terms of dy by dx, because here dy by dx is 0, and if this option is correct, then dy by dt is related with dy by dx in a linear way. जैसे यहाँ पे देखो, y को हमने ऐसे लिखा, dy by dt if you calculate you will get this, dy by dx if you calculate you will get something like this, right? देन एक्स को वेरिएबल की तरह ट्रीट किया है, टी को कांस्टेंट की तरह, देन यू विल गेट दिस as the thing. Now if you divide this to dy by dt by dy by dx is minus omega by k, and you already know omega by k क्या होता है. This is the wave velocity. dy by dt is what? Particle velocity. So particle velocity is equal to minus b omega dy by dx. This is an important relation. So here, since dy by dx is 0, velocity will be what? 0, and hence this option is correct. Option B में जाओ. Particle located at t at this point has its velocity in the negative direction. So if you see here, if you draw the tangent here, here dy by dx is what? Dy by dx is positive, right? And velocity का अगर आप relation देखो, vp equal to negative of vw dy by dx. This is positive quantity, right? And this is positive from the diagram. So overall vp is what? It is negative. So second option is also correct. Change in pressure at S is 0. Now, in case of sound wave, we talk about pressure, how we will calculate change in pressure or something. So for that, I have also written over here. Let's assume there is this air at equilibrium. These are the air particles at what? At equilibrium. Okay? And let's consider a section of air particle. Let's say this is at x, and this much air particle is at x plus dx. What is its original volume if I write? So this is dx, and let's say this area of cross section is a, then original volume is how much? A dx. And as the sound wave will move through it, either it will compress it or rarefact it, right? So in both the cases, pressure is going to change. Done it? And how the pressure will change? Because of sound wave traveling through it. अगर ये compress होता है, या फिर let's say ये rarefact हो रहा है, इसके particles के बीच की distance बढ़ेगी, and this region which is of width dx, it may become of width what? dy or something. ठीक है? So here I said कि displacement is y. Here displacement is y plus dy. So change in displacement is going to be dy. ठीक है? So bulk modulus से compare कर दोगे. Knowing these things are important. That is why I have written here. You should know from where it is coming. क्योंकि JEE advanced questions are not directly from the formula. You should know from where things are coming. So bulk modulus is what? Change in pressure. by change in volume by original volume. So here change in pressure can be written like this. Now what is the original volume that I took? A dx. What is the change in volume that we are noticing? A dy, because dy is the change in displacement. So what is dp here? Minus beta dy by dx. So this is an important relation again. अब आप चेक कर लो चीजों को. So change in pressure at s dy by dx is 0. So yeah, s 0. Particle located near air are under compression. R point को आप ध्यान से देखो यहाँ पे आपका slope क्या है? Slope is this. So this slope is negative. Change in pressure is how much? Change in pressure negative of beta dy by dx. dy by dx is negative. So change in pressure is your positive. And pressure change is positive means final pressure is increasing. Pressure increases in compression. Done it? So D is also correct. So these are the relations. Now let's do this. Okay. तुम लोगों से मेरा रिक्वेस्ट है क्वेश्चन को ध्यान से पढ़ो और सभी लोग डायग्राम बना लो. ठीक है. So do that. Read it carefully. Draw the things. Yes. Any clue? Okay, let's discuss. So, what is the question given? देखो मैंने diagram already बना रखा है. So, we are having 2 points, and at those 2 points, there are two sources, right? At point M and N. One is producing sound of frequency 118 hertz, another 121 hertz. Now, there is a car which is at point P, done just at a distance of 1800 meter or kilometer, meter it should be. That is, yes, 1800 meter from the point Q. And then this car starts moving along this perpendicular bisector, right, towards point Q, with a constant speed of 60 kilometer per hour. Then we are asked different things. We are asked how the beat frequency will change with time as this person or as this car will approach Q and then move to R. Okay? So this car has to move from P to R. Done it? And during this time, we have to tell how the beat frequency is going to change. If not the exact diagram of how frequency is changing with the time, roughly we can guess from the diagram which one is going to be correct. And then we need to talk about what Oh, really sorry. Actually, my phone got dead. I couldn't see the charge thing. Sorry. And that is why this problem happened. Anyway, so we were discussing, am I audible, everybody? Am I audible? Okay. Am I not? Yes, you can just give thumbs up. Okay. Ankit, ठीक है. So what is happening here? Car is there P. When it is moving from P to Q, what you can see here, just combine this. I mean, who is hearing what sound and because of which beat is getting generated. Beat का मतलब क्या होता है? Difference in frequencies. ठीक है? So there is a person sitting in the car. He or she is driving. So he or she will hear two frequencies, one coming from source M and another coming from source N. Now, these two frequencies getting heard by person sitting inside car cannot be equal to 118 hertz and 121 hertz, because here this observer is moving, right? Now, if you say what is the line joining observer and source M? So at any instant of time t, let's say a car is here. So at this time, this is the line joining. So it seems like this car has a velocity in this direction towards the source, right? डन है. सो इट्स वेलोसिटी विल हैव टू कंपोनेंट, जैसे डॉपलर इफेक्ट में आप लोगों ने पढ़ा होगा. दिस इज द कार, ठीक है. इट हैज वेलोसिटी v एंड हियर इज द सोर्स, ठीक है. सो व्हाट इज द कंपोनेंट ऑफ वेलोसिटी? लेट्स से दिस एंगल इज थीटा, सो दिस एंगल इज v cos theta. It will have one more component, and that is equal to how much? This will be this, which is perpendicular to the line joining source and observer. ठीक है. So this is your v sin theta, and we know that because of velocity being perpendicular to line joining source and observer, they won't be Doppler effect. ठीक है. So v sin theta is not going to contribute in that. Because of that difference in frequencies, it won't be hearing. ठीक है. So because of v cos theta, which is velocity along the source, Doppler effect is going to come. So if you write frequency of sound getting heard by this person from here will be what? Frequency को क्या लिखोगे आप? F naught is 118 hertz. So you are going to write F naught. And what is the case here? Who is moving towards what? So here is the observer. Observer is moving towards the source. And अभी अभी हमने formula में पढ़ा था, if observer moves towards source, sign is positive. So here we will write V plus V naught divided by V. This is the frequency it is going to hear. So velocity of sound को v रहने दो. V naught is how much? 60 kilometer per hour by v into 118. Again, velocity को मैंने 60 ले लिया. That is a mistake. ठीक है. This I should not do because v cos theta will be coming into account. So let's write here v plus v cos theta, v naught cos theta rather. ठीक है. Let's say this is the velocity v naught. This divided by velocity of sound. It is like this into 118. That is F1. Let's say this is F1. Okay, so this is one frequency it is hearing. What will be the another frequency? That will come from N. If you talk about N, then here also what is happening? Source, observer is moving towards the source. So if double dash, if you calculate, that will be equal to how much? F naught V plus V naught cos theta by V into F2. Right? If you calculate beat frequency at any general time, if you calculate the beat frequency, what value you will be getting? F dash minus F double dash. अगर मैं इसको solve करूं, I will be getting V plus V naught cos theta by V. This is 118 minus V plus V naught cos theta divided by V, and this is 121. If you go on to solve it, अगर आप इसको solve करते हो, what you are going to get? This is 1 plus V naught cos theta by V, and this is your 118 minus 1 plus V naught cos theta by V, and this is your how much? 121. So 118 और रादर मुझे इसको माइनस करना चाहिए था इससे, अगर मैं इसको ऐसे कर देती हूँ, ठीक है। सो इफ यू डू इट, 121 माइनस 118 विल बी 3। 3 प्लस हाउ मच वी आर गोइंग टू गेट, वी नॉट कॉस थीटा बाई वी इंटू 118 प्लस वी नॉट cos theta by v into 1 to 1. This is what we are going to get, right? If we have to check for frequency at point P, R, and Q. Beat frequency at point P, R is where R and Q. So at Q point, if you talk about, at Q point, angle theta will become what? If you see here, theta कितना हो जाएगा बताओ? Theta is angle between vertical line and this line joining this vertical line and line joining observer and the source. So here line joining observer and the source is what? It is this. And what is the vertical line? This. So angle is this, right? So as we are moving down, this angle is what? This angle is gradually increasing, as you can see here. Will it be 90 or not? What do you think? Yes. So if you write that here, theta को आप 90 लिखोगे, what will be the value of beat frequency at point Q you will be getting? So this will become 0, this will become 0. You will be only left with 3. So VQ is equal to 3. And if we calculate, VP, then for VP, if you write, VP के लिए we will be getting certain value of angle. So let's not calculate it. Let's just compare, क्योंकि हमें देखना है it is VP plus VR is equal to 2VQ or not. So VP कितना है हमारा? VP is this. डन है। VP को आप ऐसे लिख डालो, 3 प्लस V नॉट cos थीटा बाई V इंटू 118 प्लस V naught cos theta by V into 1 to 1. If you calculate VR, R के साथ क्या change होगा? Let's see. If you are at point R, if the bus has reached or car has reached point R, it is going like this. And if you combine this point with this, then it seems like this observer is moving away from the source. Because when car is at point Q, it is at this distance. When it is at this point, it is further moving away. As it is traveling from Q to R, observer is moving away from the source, right? When it was moving from P to Q, it was moving towards the source. Now, from Q to R, it will move away from the source. So, now if you go on to calculate frequency, आप कैसे लिखोगे बताओ? So, F1 will be equal to what? Away from the source जा रहा है. So, earlier we did plus, now we will be doing minus. Theta will remain same. I mean, at point P and at point R, theta is same, right? Because these 2 points are quite symmetrical. सो सिंपली यहाँ पे माइनस का टर्म आ जाएगा। डन है। प्लस की जगह क्या होगा? माइनस। सो यू सिंपली राइट हियर F1 will be equal to V minus V naught cos theta by V into 118, and another will be how much? V minus V naught what? Cos theta by V into this is what? 1 to 1. So you just need to subtract these two now in order to get. हमने यहाँ कुछ गलती किया है, तुम लोगों को दिखा नहीं क्या? माइनस करेंगे, एक साइन माइनस में जाएगा। ओके, यस, कैलकुलेशन में मिस्टेक है यहाँ पे, क्योंकि हमने एक को दूसरे के साथ माइनस किया था ना। एक सेकेंड, इसको माइनस किया, ये प्लस था। सो दिस टर्म इज दिस बिकेम -1 -118 plus 1 to 1. This is minus V naught cos theta by V. And yes, this is minus, this is plus, right? So which one was minus? This one is minus and this one is plus. ठीक है? Now let's write this thing. इसको अगर आप minus करोगे, F2 minus F1, you can do the minus thing now. ठीक है? I won't be solving it क्योंकि lengthy होगा. You can do it easily and you will check if VP plus VR is equal to 2VQ or not. ऐसा दिख रहा है कि इक्वल होने वाला है। VP plus VR 6 आएगा, क्योंकि जब आप उसको ऐड करोगे ना, यहाँ पे 3 - समथिंग आया है, देयर यू विल गेट दिस प्लस एंड दिस माइनस, सो ओवरऑल 3 + 3 6 हो जाएगा. इफ यू विल डू VP + VR, दैट विल बी इक्वल टू 6. So that will be correct basically. The rate of change of beat frequency is maximum when the car passes through Q. So this question can be answered just by letting you know जो अभी सोहेल ने पूछा था. So what is happening over here? यहाँ पे था तुम्हारा point Q था, right? Here the observer is moving. ठीक है. So when observer is moving towards point Q, it is moving towards the source, and when it is going this side, it is moving away from the source. But if you concentrate around this region, what is happening? There is sudden change of concept is happening. Change of concept meaning just before this Q point, observer was moving towards the source, and just after it, what is happening? Observer is moving away from the source. It is moving away from the source. Done it? And when this sudden change happens, na, frequency change is more. Done it? Because if you talk about this point or this point, what is the change? Only the change is in angle. So when you were writing the formula V plus V naught cos theta divided by V into F1, what is the change here? Change is simply theta को आप change करते जाओ. How cos theta will change? Cos theta के change का range क्या होगा? It will be what? In this range, right? Magnitude की मैं बात कर रही हूँ. It will be in this range. So this is not going to change much. But if you talk about crossing this point, then this will become how much? V minus V naught cos theta by V. So there is a sudden jump. There is a sudden change jump, right? And that is why we can say that rate of change in beat frequency is maximum when the car passes through Q. और जब Q को cross करेगा ना, this change will be fast. Done it? So option D looks correct. And if option D is correct, then graph A is correct. क्योंकि A के लिए आप मिडिल पॉइंट पे देखो, यहाँ पे दिस इज VT वर्सेस T, चेंज का ग्राफ है. एंड दिस चेंज का रेट इज व्हाट? रेट हियर यू कैन सी द स्लोप is quite slopy. I mean, its value is higher. And here the slope is flat. So here change क्या दिखा रहा है? Change दिखा रहा है कि almost नहीं हो रहा. Change is minimum around point Q. And here it shows that change is maximum around point Q. So this is correct, right? क्योंकि around point Q change will be maximum. Concept ही change हो रहा है. So this will be maximum. इस तरह से आप इसको
मैम
क्या कर सकते हो? Yes.
मैम इसमें टाइम के साथ रिलेशन कैसे निकालेंगे? कॉस थीटा को फिर मतलब ये डिस्टेंस को
डिफरेंशिएट
कुछ
कर
लिखना
सकते
होगा ना?
हो. हाँ, कर सकते हो. कर सकते हो, बट जरूरत नहीं है, इसलिए मैंने नहीं किया. जैसे यहाँ पे तुमने निकाला ना चेंज, आई मीन हियर इज द बीट फ्रीक्वेंसी, राइट? दिस इज द फॉर्मूला यू आर गेटिंग. डन है. इसको मैं कैसे लिख सकती हूँ? इसको मैं सिंपली लिख सकती हूँ 3 + V naught cos theta by V into 3. So you can simply write it like 3 into 1 plus V naught cos theta by V. So you can change here, you can check here. This is the beat frequency. Beat frequency का value कितना आ रहा है? 3 1 plus V naught cos theta by V. You can simply differentiate it also with theta, and theta is what? Theta is changing with time, right? The way theta is changing with time, the same way we can assume that frequency is also changing with the time. So dVn by d theta करके आप check कर सकते हो. So if you will do here, you will get this is constant, and this will become 3 V naught minus sin theta by V. ठीक है. So at the point Q, as I told you, theta क्या हो रहा है? 90. थीटा मैक्सिमम जा रहा है. So इस चेंज का जो रेशियो है ना, जो चेंज का रेट है, दैट इज मैक्सिमम अराउंड पॉइंट Q, बिकॉज थीटा इज बिकमिंग मैक्सिमम. ठीक है. सो दैट वे ऑल्सो यू कैन गो, आई मीन कैलकुलेशन से. बट ऐसे भी दिस दिस इज ऑल्सो लुकिंग क्लियर. Q के अराउंड चेंज मैक्स होगा. यू कैन डू आइदर. चलो, दिस इज एक्सपेरिमेंट. आई एक्चुअली वांटेड टू टेल यू अबाउट दिस. सो टाइम कम है, इसलिए मैं एक काम करूंगी. आई विल सिंपली एक्सप्लेन यू द एक्सपेरिमेंट. ये एक्सपेरिमेंट तुम लोगों को इंक्लूडेड है. तो एक्सपेरिमेंट क्या है? एक्सपेरिमेंट इज टू कैलकुलेट स्पीड ऑफ साउंड यूजिंग रेजोनेंस एयर कॉलम मेथड. सो इस मेथड में हम करते क्या है? इस मेथड में कुछ नहीं करना होता, सिंपल है. सम हाइट तक वाटर होता है, ठीक है. सम हाइट तक वाटर है, और एंड वी कैन चेंज द हाइट ऑफ वाटर यूजिंग सम टैप और डिवाइस अटैच्ड ओवर हियर, ठीक है। उसके बाद वी हैव अ वाइब्रेटर, यानी कि वी हैव अ सोर्स व्हिच फ्रीक्वेंसी वी नो ऑलरेडी। सो जिसको हम लोग ट्यूनिंग फॉक बोलते हैं, ठीक है। सो हाउ वी कीप दैट ट्यूनिंग फॉक, जैसे देखो, अगर अगर यहाँ पे एयर फील्ड है, क्योंकि टू सर्टेन हाइट देर इज वाटर, देन देर इज एयर। If you have to let this air vibrate with certain frequency so that you can calculate velocity of sound in there, then I mean, how you will vibrate your vibrator? उसको ऐसे ऐसे वाइब्रेट करोगे वर्टिकली या फिर ऐसे ऐसे हॉरिजेंटली? अगर जैसे ये बीकर रखा हुआ है ना, यहाँ पे बीकर है और तुम ऐसे ऐसे वाइब्रेट कर रहे हो, देन दैट वाइब्रेटर विल डिस्टर्ब एयर इन दिस atmosphere, right? But you have to basically disturb air of this container. Disturb कहने का मतलब, you have to make this resonate, done है? And that is for and in order to gain this you will be vibrating it vertically, not horizontally. So यहाँ पे एक option था, the prongs of the tuning fork were kept in a horizontal plane above the resonance tube. No, it will be kept in a vertical plane, then only it will be able to set this air column into vibration, otherwise it won't be able to. So option B is what? Wrong. ठीक है। नाउ लेट्स टॉक अबाउट द इंटेंसिटी ऑफ साउंड हर्ड। अब देखो यहाँ से स्पीड निकलता कैसे है, कोई फॉर्मूला ऐसा सिंपल लगाना है तुम्हें। सपोज कर लो हमें मिल रहा है सिंगल फंडामेंटल मोड मिल रहा है, तो यू विल मेजर द कॉलम ऑफ एयर, लेट्स से दिस इज एल। एल यू विल इक्वेट टू लैम्डा बाई 4। लैम्डा को आप क्या लिखते हो? सी बाई लैम्डा is your frequency, so lambda can be written as c by frequency into 4. You already know the frequency, you know the length, you can calculate the speed of wave, right? So this way we calculate the speed of wave. Let's talk about more options here. The intensity of sound heard at the first resonance was more than that at the second resonance. Now we cannot say this from the statement. यहाँ पे देखो क्वेश्चन को पढ़ो। The resonance with the shorter air column is the first resonance, and that with the longer air column is the second resonance. I told you before, you can change the height of water column and hence air column. So with the longer air column, we are getting second resonance. So second resonance we are getting for longer air column. एंड इफ एयर कॉलम इज लॉन्गर, जैसे तुम यहाँ, मैं यहाँ बोल रही हूँ, somebody sitting in Delhi cannot hear me, है ना? somebody sitting even 1 kilometer afar cannot hear me. Why? हमारे और उसके बीच में 1 किलोमीटर का एयर कॉलम है, एंड इन दैट 1 किलोमीटर एयर कॉलम माई साउंड एनर्जी गॉट, आई मीन गॉट लॉस्ट, ठीक है। सो मोर द एयर कॉलम, जितना लंबा एयर कॉलम होगा उतना एनर्जी का डिसिपेशन होगा, आई वुड से। So the intensity of sound heard at the first resonance is occurring in short air column. So yes, here the intensity will be more, and then that at the second resonance, which is happening with longer air column. So first statement looks correct. C क्या है? The amplitude of vibration of ends of prong is typically around 1 centimeter. देखो यहाँ पे जो prong है ना, this is just a experimental thing. You cannot measure its amplitude. Simply you cannot measure it. ठीक है। So आई मीन यहाँ पे कंफ्यूजन ये हो सकता है कि जो हमारा अंदर जो वाइब्रेशन सेट कर रहे हो ना, उसका एम्पलीट्यूड एक्चुअली वी कीप अप टू 1 सेंटीमीटर सो दैट वी कैन मेजर इट, ठीक है, रफली, सो दैट वी कैन, एक सेकेंड, लैम्डा को हमने ब्रेक किया था ना, और वी आर रिक्वायर्ड टू कैलकुलेट, यस। देखो यहाँ से हम लैम्डा डायरेक्टली कैलकुलेट नहीं कर सकते, बिकॉज I mean it's something sort of limitation of the experiment. We cannot exactly measure it, done it, but it is around, uh, it is kept around 1 centimeter. It's our target to keep it around 1 centimeter so that we can measure it. But still I mean we somehow fail to measure it, and that is why C को हम सही नहीं कह सकते, इसको गलत बोलेंगे। द एम्पलीट्यूड ऑफ वाइब्रेशन ऑफ द एंड्स ऑफ प्रॉन्ग, क्योंकि अगर तुम इमेजिन करो ना, वाइब्रेटर बहुत जल्दी वाइब्रेट करता है, उसके एम्पलीट्यूड को मेजर करना मुश्किल है। यस, यहाँ पे जो रेजोनेंस कॉलम हो रहा है उसके एम्पलीट्यूड को हम मेजर कर सकते हैं, दैट इज नियरली अबाउट 1 सेंटीमीटर, बट दैट ऑल्सो वी कैनॉट डू दैट एक्यूरेटली। बट प्रॉन्स के एम्पलीट्यूड को मेजर करना इज नियर अबाउट इम्पॉसिबल, वी कैनॉट डू इट। and that is why this is wrong. The length of air column at the first resonance was somewhat shorter than 1/4 of the wavelength of the sound in air. The length of first air column, ठीक है, एट द फर्स्ट रेजोनेंस. सो फर्स्ट रेजोनेंस तुम्हारा कैसा होगा? फर्स्ट रेजोनेंस देखो, एक एंड तो वाटर है, वहां पे मुझे क्या मिलने वाला है? वहां पे नोड मिलेगा. सो एंड विल बी योर व्हाट? एंटी नोड. एंड यू हैव लर्नड अबाउट एंड करेक्शन. एंड करेक्शन ये कहता है कि इफ दिस कॉलम लेंथ इज एल and this wavelength is measured at how much? This is equal to how much? Lambda by 4. So lambda by 4 is not equal to L, it is equal to L plus E. End correction. Because this is not exactly up to here, somewhat it will be out of the container, so that is why we include end correction, which is equal to 0.3 into diameter of this tube. ठीक है. So when both side there is air column and you are getting resonance like this, यहाँ पे भी end correction लगाओगे, यहाँ पे लगाओगे, but here there is only one side, it is open to the air, so only one end correction. This is this. So basically length is not equal to lambda by 4, it is somewhat larger than that. So the length of air column at the first resonance was somewhat shorter than the wavelength of the thing. So yes, length is shorter, right? Length is what? Length को अगर आप लिखो तो lambda by 4 minus e. So yes, it is shorter than what? Lambda by 4. Sorry, I told greater. No, it's shorter. ठीक है. This is also from basic concept. चलो कॉन्सेप्ट वाले कर लेते हैं. ज्यादा क्वेश्चंस आता नहीं है, क्वेश्चंस कम ही आते हैं इससे, लेकिन जो भी आएंगे इजीली हो जाएंगे, एंड दैट इज व्हाई वी शुड बी क्लियर विद द कॉन्सेप्ट्स. चलो इसको भी मैं एक्सप्लेन कर देती हूँ. क्वेश्चन ये है सिंपल. देयर इज अ पर्सन दैट ब्लोज इनटू ओपन एंड ऑफ ए लॉन्ग पाइप. सो देयर इज ए लॉन्ग पाइप. ठीक है. एज ए रिजल्ट, हाई प्रेशर पल्स ऑफ एयर ट्रेवल्स डाउन द पाइप. सो डाउन द पाइप हाई प्रेशर पल्स जा रहा है, यानी कि कॉम्प्रेशन जा रहा है. ठीक है. When this pulse reaches the other end of the pipe, this is also open. ठीक है. Then what? How the wave will travel up? So तुम लोगों ने पढ़ा होगा, जब प्रेशर वेव होता है और डिस्प्लेसमेंट वेव होता है, they are out of each other by phase of what? Anyone?
मैम प्रेशर में शायद कोस का फंक्शन होता है, डिस्प्लेसमेंट साइन में साइन का
हाँ,
फंक्शन होता है.
तो 90 का डिफरेंस है, राइट?
हम्म.
हाँ. तो 90 से आउट होता है. इसके कहने का ये मतलब है कि जो अभी तक हमने डिस्प्लेसमेंट को डील किया था, वी टॉक्ड अबाउट हियर देयर इज डिस्प्लेसमेंट. एंटी नोड विल बी ऑलवेज इफ दिस पॉइंट इज ओपन, राइट? सो अगर ये पॉइंट ओपन है तो हियर यू विल बी गेटिंग द मैक्सिमम एम्पलीट्यूड लाइक दिस. ठीक है. And if also this point is open, then here also we will be getting maximum displacement. But if you talk about the pressure, then at this open end, you won't be getting what? Maximum pressure. You will be getting minimum pressure. ठीक है. So इसी concept को दिमाग में रखना है. A high pressure pulse starts traveling up the pipe if the other end of pipe is open. अगर अदर एंड ऑफ पाइप इज ओपन, तो क्या हाई प्रेशर पल्स ट्रैवल करेगा? क्या होगा? बताओ. अच्छा, एक चीज मुझे बताओ. चलो ठीक है. एक चीज आप बताओ, यहाँ पे ऐसा है, दिस इज रिजिड एंड. ठीक है. तुमने एक वेव को ऐसे भेजा, हाउ इट विल कम बैक? कैसे आएगा बताओ मुझे. दिस इज फिक्स एंड. ठीक है. दिस इज फिक्स एंड. हाउ इट विल रिफ्लेक्ट बैक? दैट इज व्हाट आई एम आस्किंग.
हम
यहाँ
पाई
पे
के
क्या?
फेस.
हाँ. सो यहाँ पे पाई का फेज तो होगा ही होगा, साथ साथ एक और चीज होगा. अगर आई मीन यहाँ पे तुम्हें क्या मिला है? मैक्सिमम मिला है ना. डाउनवर्ड डायरेक्शन में मैक्सिमम डिस्प्लेसमेंट है. जैसे इसका फेज तुम्हारा किससे चेंज होगा? पाई से चेंज होगा. सो इट विल गो लाइक दिस. और ये इसलिए ऐसा हो रहा है ना, क्योंकि देखो ये वाला पॉइंट जब यहाँ पे पहुंचेगा इट विल ट्राई टू पुश इट डाउन विद दिस डिस्टेंस, बट सिंस इट इज रिजिड इट कैनॉट गो डाउन बाय दैट डिस्टेंस. Then reflected wave will instantaneously get generated, which will try to pull it up by the same distance, and hence net resultant will be what? Zero. So here, if maximum displacement is coming in the down sense, here when reflection will happen, maximum displacement in the up sense we will get. It is like this. So phase change of phi. ठीक है. And here what we will, how we will deal with this pressure thing. बताओ. अब मुझे आंसर करके बताओ क्या क्या हो सकता है. Open end means not fixed end. That is open, not fixed. ठीक है. जैसे यहाँ पे अगर तुम्हारा फिक्स एंड नहीं होता ना, अगर यहाँ पे ओपन एंड होता तो ये जैसे था वैसे ही ऐसे वापस आ जाता, ओनली इट्स डायरेक्शन वुड हैव रिवर्स्ड लाइक दिस. ठीक है. डिस्प्लेसमेंट विल रिमेन सेम. एंड जो डिस्प्लेसमेंट के लिए पढ़ रहे हो उससे जस्ट ऑपोजिट कर दो प्रेशर के लिए. अगर लेट्स आंसर दिस क्वेश्चन फॉर डिस्प्लेसमेंट थिंग. अगर डिस्प्लेसमेंट का यहाँ पे मैक्सिमम आता है, सिंस दिस इज फ्री एंड, जब वापस जाएगा तब भी कैसा जाएगा वो? मैक्सिमम जाएगा. बट हियर वी आर टॉकिंग अबाउट व्हाट? वी आर टॉकिंग अबाउट प्रेशर वेव. सो इफ प्रेशर का मैक्सिमम आ रहा है तो मिनिमम जाएगा. ठीक है. So high pressure pulse starts traveling up? No, it will be correct because it will be true for displacement wave. And low pressure pulse start traveling up? Yes, क्योंकि incident हुआ है high pressure. Done it? So B is correct. And yes, the opposite will be true for what? If the other end is closed. अगर आपने इसको close कर दिया तो traveling wave के लिए क्या होता तुम्हारा? Traveling wave के लिए क्या हो जाता? I mean, just do the opposite. I mean, in case of open end, high pressure wave is becoming low pressure wave. In case of close end, high pressure wave will revert back as high pressure wave. So option B and D will go as correct. ठीक है. सो ऐसे कर सकते हो. प्लीज रिवाइज थिंग्स. ठीक है. यहाँ से क्वेश्चंस बहुत ही इजी आते हैं. एक और क्वेश्चन मैंने इंक्लूड किया था, बस ये था. अगेन इसको तुम ऐड कर सकते हो सिंपली द वे आई हैव टोल्ड यू हाउ टू ऐड थ्री वेक्टर्स. आई मीन हाउ टू ऐड थ्री वेव्स टेकिंग देम एज अ वेक्टर. सो ये क्वेश्चन बहुत ही इजी. देन देयर इज दिस क्वेश्चन. टू मोर क्वेश्चंस आर लेफ्ट. ठीक है. आई विल बी शेयरिंग द स्लाइड, यू विल बी डूइंग द क्वेश्चंस. ठीक है. चलो, एनीवन हैज एनी डाउट देन लेट मी नो इफ यू हैव. ओके. इफ नो डाउट देन वी आर गुड टू गो. चलो, everyone take care of yourself and keep solving more questions. Keep your spirit high. I mean, only way to keep your spirit high is by doing more number of questions. So जितना टाइम मिले क्वेश्चन करो, खुद को रिलैक्स रखो. ठीक है. बाय एवरीवन, टेक केयर.